All right, good morning, everyone. It's nice to see you here. We started to think about what is it that actually matters in the life sciences, and I guess the closest business I come up with was this idea, we were just still at, was this idea of data integrity. And data integrity is this concept that encompasses the lineage of your data, where it came from, who touched it last, how do we know that we did what we said we did, is the data in the original form as it was on an electric instrument. And so I want to give you some very practical tips. First, what I'm going to do is set the overview, and as you move data from discovery to translational and clinical, talk about some of the structural challenges, why that's hard, why teams feel overwhelmed when they're faced with it. I then specifically want to talk about this concept. How many people are familiar with data perimeters? I want to specifically talk about the concept of a data perimeter, and then I'm going to go into some concrete tips for GXP compliance. How many people have heard of Barroom's Law? Does this look familiar in any way? So if you're familiar with Gordon Moore made this observation that every 18 months, you can double the amount of transistors that you could put on a die in a semiconductor. And Barroom's Law is this very depressing observation that for every billion dollars that we spend on drug discovery, we're producing about half as many breakthroughs. And this happens every 9 years or so. There was actually a Nature Reviews drug discovery paper on this law. And I think part of Barroom's Law really has to do with data integrity, and has to do with the fact that by the time that we get into clinical phase, a lot of times what we're doing is rerunning experiments that we should be able to trust from the past, because essentially we don't have a time machine. So I'm going to talk more about Barroom's Law in a second. It shouldn't be any secret why Barroom's Law is a factor. If you can't read this, you're doing it right. I mean, the idea here is that the compliance process, I've got both biologics and small molecules up here. The compliance and verification process is extremely tedious and is multi-step. And this complexity is exacerbated by the fact that there are different incentives at each stage of the, clinical process, or the process that leads to a drug discovery or a new therapeutic reaching the market. And the pressure you feel at the discovery phase is just the lab manager just like praying, do more experiments, run more experiments, run more experiments. When you get to translational, you start to have an idea of which targets and which products could be interesting. And then by the time you get to clinical, now the FDA is going to be looking at the data. Your customers, if you're selling to a large pharma, are going to be looking at the data. And you start to feel this gurgle in your stomach that, hey, did we really do things right? And so the idea, you can see here people going from an exclamation mark to a question mark. And I think Gregory Benford, he's an astrophysicist and science fiction author, he summarized this really well. And he said, passion is inversely proportional to the kind of real information available. So as we go down this funnel, it becomes harder and harder to become excited. And the thing that we're actually missing, the magic wand that we're missing is a time machine, right? Why is that the case? During discovery, you're cranking experiments. Let's say you do 1,000, let's say you do 10,000. You don't know until 18 months later which one of those is going to actually become interesting. So the superpower that your organization needs is the ability to go back in time without doing a lot of very painful data archaeology and find the inputs and the outputs exactly as they were at the time that they came off the instrument. And this is kind of where the concept of version control comes in. And it isn't just about version control. Everybody who's used a system like Git or Quilt knows that you can travel time and move back to a previous snapshot. But it's critical that all those snapshots in time themselves are immutable. What does that immutable mean? That means that with cryptographic certainty, none of those snapshots can change. We'll talk more about how you can verify that in just a moment. And in this context, I think most of the people in this room, I think we have a mix of technical folks and scientists, is that what you want to communicate to the business shouldn't be about GXP. It shouldn't even be about data integrity. It should be about a human scale concept that we call the data chain of custody. And at the end of the day, if you want to summarize this discovery, translational, clinical journey, you can think about something comes off an instrument, it goes into the hands of a scientist, it gets analyzed, and ultimately ends up in a file, in some cases. And so this data chain of custody is this concept that everything you build in your organization, every output is immutable, and you link these together in a lineage chain, and that's what actually goes to your file. And to be a little bit more precise, I have this concept called PEP, which is packages, events, pipelines. And I'm not going to talk deeply about directed acyclic graphs in this talk. I've given other talks on that. But the key idea is that every product your organization produces is a chain of PEPs. What does that mean? It's a chain built out of events which sponsor pipelines which produce value. And again, what this gives you at the end of the day is when you go into compliance and you hand an auditor or you hand the FDA or you hand a European agency that last note, they can peel back the chain and trustably verify for themselves that your data has the integrity that you claim it has. Okay, so I'll get practical in just a moment here. Just going back, I want to emphasize this data chain of custody is not just an abstract concept. It's something that we've built into the product. Anybody that's used the Quilt catalog knows our revision history. And this is the beginning of fleshing out this data chain of custody idea, is that you can see all the mutations to the data. And again, you'll notice there in that menu, you have that hash. That hash can be used by a third party. That's what's trustless about it, is that cryptographic hash is like a digital fingerprint of the data, and it is not physically possible with very high probability to change data without also implicating the change to the hash. And this is what tells you that your data essentially this is what tells your auditors that your data hasn't been tampered. So there's kind of two parts that I want to break the meat of the talk down into. One is security and the other is compliance. And I want to start with the security piece on data perimeters. So it seemed at the outset that a lot of people weren't familiar with data perimeters. They had a very simple definition with some pretty interesting implications. So the idea behind a data perimeter is that only trusted identities can access trusted resources from expected networks. And notice we've used the word trusted twice and the word expected once, and I'm going to explain what that means in just a second. The structural barrier to this is that by default, a lot of the AWS defaults aren't always the right ones. Okay, and I'll give you an example. When you use SNS, when you use S3, when you use Elasticsearch, the public endpoints are the default, and you, under the shared responsibility model, you, the customer of AWS, have to do extra work to make sure they're using private endpoints and private writing. I'm going to talk more about that. The other issue that we'll see with some of the defaults, and when I talk specifically about encryption in S3, is that there's only one layer of identity verification. And again, in the shared responsibility model, I'll explain what that means in just a second, it's your responsibility as a customer to enable those controls. Just to show you a little bit about data perimeters in practice, I want you just to focus for a second your attention on Amazon S3 on the far right there. So there are different ways that services in your VPC, in your private cloud, can access data in an S3 bucket. The gateway endpoints are per region. They work through the routing tables, and the interface endpoints actually tend to work through DNS routing. You only have gateway endpoints in Amazon for S3 and Dynamo. That's kind of the legacy way of doing things to the routing table. But the key thing here is that those services allow you to access S3 from your private cloud. They do not prevent people from the public cloud from accessing S3. Does that part make sense? So the short of what I'm trying to say here is that there are strong security controls that you can provide that will place effectively the S3 bucket inside your virtual private cloud. So that clients have to be within your VPC, within your VPN in order to gain access to that data. And I want to talk a little bit about how that works. So I just explained that by default, so let me show you an example of what not having a data perimeter looks like. And we live in an era where we have what are called supply chain attacks, where it's not even your infrastructure that gets attacked, but third-party infrastructure that you buy that gets attacked. And what this essentially means is, by default, if the S3 credentials are exfiltrated, your VPC, your VPN all of a sudden don't mean anything, right? What does that mean? If I have an S3 key secret pair, if I have an AWS key secret pair and it allows me to get object on that bucket, I don't have to be on the VPN. I can still gain access to that bucket. There is a little bit of a mitigation here. You can tie your AWS credentials to SSO, but that isn't enough because those credentials now have a limited blast radius, a limited duration. But again, if the credentials are exfiltrated or you have long-lived credentials that are exfiltrated, people can still access S3 without being on a trusted network. So again, to take this back to the concept of a data perimeter, what we're saying is that the trusted network aspect is really on the customer config, and I want to give you some examples I do that. So this is actually written as, think of this as a resource policy, and I'm going to explain how you can implement it for the entire organization as a service control policy. This is a standard resource policy, and I'm just going to break it down. So the SID tells us what we're going to do in the subsequent statements, and what I want you to notice is that we are starting with a deny. Okay, so the negation of the issues that we're about to see are what is going to allow access. The little finesse here is the resource. This is actually a service control policy. I lied. It's not a resource policy. The service control policy allows you to provide, you can apply a resource policy essentially to a whole class of resources. You don't have to use this per bucket. And the key idea here is quote star means we're going to apply this to any bucket or objects in any bucket that have the name quilt. But there are a variety of ways you do this. You could probably enforce this through tags. Okay, now let's get into the interesting part of things here. So the first thing is that if the source VPC is not either from your local, it is not from the VPN or the VPC, you then are going to deny access to the S3 bucket. So this is actually putting this hard perimeter around the S3 bucket. And now somebody with S3 credentials is not going to be able to perform get object or any of the other items on the bucket. Because service control policies are a very strong medicine, we actually do recommend that you provide, that's an escape hatch there where if you have a principal, let me explain. When you apply these kinds of policies, you can actually lock the Amazon console out of the S3 bucket. And then you can't administer that S3 bucket, it becomes highly problematic. And so the purpose of this network restricted exempt tag is just to provide a tag so that when you screw this up, you can actually drop that tag on a principal and go in and administer the bucket. There's two other aspects to the data perimeter control here. And one is you'll notice that you can have CIDR blocks that represent which IP sources are legal for ingress. And this is, again, adding that known networks part to the data perimeter. And then finally, we do allow access for AWS principals. Hopefully that data sets. Any quick questions or comments? Okay, I will publish all these slides so that they're clear. I promised to talk about encryption as well. And this is a good example here. We're going with the default. So SSE stands for server-side encryption. And there is both SSE S3 and SSE KMS. And I want to show you the difference between these two types of server-side encryption with respect to a data perimeter. And what I want you to notice is that SSE S3, if the get object calls succeed, you will automatically get the decrypt on object. Okay. Did anybody see a problem with this from a data perimeter perspective? A single point of failure, right? If get object works, then you actually the user gets the decrypt, or the caller gets the decrypt. KMS works slightly different, and the way it works is first when you make the get object call, you receive what is called an envelope, and that envelope notes which key is required to do the decrypt on the data. You then have to go to the key policy, and if and only if the user is on the key policy, then you will actually be able to decrypt the data. So what this does is, so let's go back to the definition of the data perimeter. You have trusted identities, trusted resources, and known networks. Which aspect does that reinforce? Checking who's on the key policy.
Trusted identities.
Correct. So that makes sure that this identity, again, security is about layers. Like you never want a single point of failure. That makes sure that the identity is also on the key policy. And from an auditing standpoint, now, how many people know, who can read? Given an object in S3, how do people know who are all the people in the organization that can repeat that? It's a really scary question to ask, right? But if you use SSE KMS, you can go to the key policy, and if you're the principal either on the key policy or not, and if the principal is not on the key policy, they can't access any data that's encrypted. So just to wrap up on the security point, you can use service control policies at the account level to restrict access to trusted S3 resources to known networks, right? That's what we just looked at. Is now you don't just need the S3 credentials, you also need to be able to pass the service control policy, which includes verifications for the networks that you're approaching the data from. And you can create private endpoints for AWS services. We looked at gateway and interface endpoints. There's a whole science to that. Prefer SSE KMS to SSE S3 and enforce known networks using a VPN, or there's a new service now called AWS Verified Access, which is designed to give you some protection to the VPN without requiring you to spin up a VPN. And we've got a link to the cool documentation on data perimeters. The last thing I want to talk about is compliance. And specifically the compliance that we see most necessary across our customer base, largely because we have a lot of US customers, is GXP. How many people, and a lot of you who are in Discovery are like, I don't care about this. and I don't blame you. I guess compliance isn't always fun, but how many people have touched GXP in some capacity? A couple. Okay. So hopefully for those of you that haven't, hopefully I will give you some familiarity with the terminology and start to give you some ideas for when you get to this phase, because I think success looks like, you could hand this off to a manufacturing further, but I think success looks like that pretty much everyone in the stream gets to this space where they're actually manufacturing things that are directed into people or adjusted by people. So GXP, that X is literally an X. So lab, manufacturing, and clinical are some of the others. There's also cloud computing, automated manufacturing, right? Automated manufacturing. There's a variety of different things that X can stand for. There are harder certifications in the industry. So I don't know if you're familiar with financial controls like SOC 1, SOC 2, and SOC 3. Those are a lot clearer because you literally have an auditor and there's literally a bunch of checkboxes and you say, I have this compliance, and they don't. GXP isn't like that. It's just a set of guidelines, a lot of which are captured in 21 CFR, the federal regulations title. And Title 21 is reserved for the FDA. And a lot of times you'll see it's reversed. You say 21 CFR. A lot of times you'll see 21 CFR Part 11 referred to in the context of software and data management, because that's just the specific part of 21 CFR that covers electronic and digital records. Okay. I also find it kind of cute that in AWS's white paper, they say good cloud computing practice, because if they said good cloud practice, so, you know. Okay, so now I want to talk to you about the shared responsibility model. And the implication of this is that AWS is responsible that the system works properly. You are responsible. It's a big responsibility too for actually applying the system controls correctly. And we just saw this example with the defaults, right? So you could use a public interface, you could use a public endpoint, you could use an interface endpoint. It's really on you to apply that configuration according to the compliance regime that you're with. So AWS's responsibility again is that things, the way they say it is AWS is responsible for security of the cloud. You are responsible for security in that cloud. There, in the GXP context, there are two kind of big terms to be familiar with. One is verification, which is about requirements. The second one is validation. And validation is about being able to consistently meet the requirements. So it's about requirements, consistency. And then I've linked to an FDA.com quality system regulation and process validation that you can look at for more information. The three Qs you should be familiar with are performance qualification, operational qualification, and installation qualification. And one of the biggest pitfalls that I see teams falling into is that they want to do this qualification manual. And what that means is they spend 3 to 6 months developing a test plan. It gets written down in Microsoft Word doc. That then gets farmed out to the quality team. The quality team then literally goes. They click button and they say this system is validated. And a lot of this, I think, is a hangover because the FDA regulations, the PQ, OQ, and IQ, were originally written for instruments, for physical instruments, which are different. Like, is the centrifuge balanced? Does it achieve a certain velocity? And these are the kinds of things you're going to think about for a physical instrument. They don't always translate well to software. And so when you're thinking about GXP validation in a software context, I want you to think a lot more about automation. And I want to give you some examples. So if you look at the lower right there, what we have done for the GXP module is, and you can do this on your own. You don't have to buy the Quilt GXP module. That's the point in this slide. Amazon has a service that's called Canaries. And these Canary synthetics are actually designed, they're called synthetics because they generate synthetic derivates. And they're designed to crawl your application and do things that the user will do. And the do things that you can program them in JavaScript or Python. The do things that the user would do is there's a headless version of Chrome that's embedded into the Canaries. And you can use Puppeteer or Selenium to pull up a browser page to do a login. And the nice thing is that because these are backed by Lambda functions, you can do all this in the private cloud. So we actually have a private SSO service, and the Canary agent you'll see on the far right there wakes up at pre-specified intervals, and it does your operational qualification or performance qualification. It can do both for you, right? And this is a complete scene change from having a person like, let's start a 6-month quality cycle and having to re-qualify and revalidate. And that is a very slow way of doing things. And so the teams that have more software agility and do things in an automated way are going to have time to market, but actually shorten it. For the actual IQ part, this is how you specify that the installation is correct. This is where infrastructure's code really shines. You can do the Terraform, you can do the CDK, you can use the CloudFormation. We simply describe stack resources, telling you what all the resources are that are running. This is like, again, analogous to the conditions that are present for the correct operation of your instrument. Actually, I think I glossed over something. Yes, I want to go back here and I want you to look at the diagram on the far right there. So you can think of these, I don't know why they're not circles, as concentric squares, so to speak. And the idea here is that the normal operating, so that you can operate without being under stress is encapsulated by performance qualification, okay? Operational qualification is under exceptional circumstances, under circumstances of load, and then installation qualification tells you that the system has actually been installed properly, okay, according to the prerequisites that are outlined in its installation routers. Another important part of GXP is being able to audit what you did. The GXP, the audit trail in Quilt is built from the CloudTrail, CloudWatch, and Athena. And then you'll see referring to it's 21 CFR Part 2 that talks about revision and change control. Sounds like version control. Revision and change control procedures to maintain an audit trail that documents time sequence development and modification of system data. And just to get a little bit nitty-gritty with that, there are a lot of questions you might want to ask yourself, or your auditors might want to ask you, their compliance regime. Here's one. Who logged in this month? Which role did they have? And did any admins do that login? I don't expect you to memorize the SQL, but the important thing is you can use the Athena interface to CloudWatch and to CloudTrail, and even to S3, to actually munge that data together and ask logical questions like this. And I think one thing to keep in mind here is that we found that we had to supplement what CloudTrail does, because CloudTrail, it is primarily logging data plane events with respect to S3, but there are other higher level application events, right? Like, did a user log in? That's not going to be CloudTrail. You can infer that they logged in if there's a get object call in CloudTrail, but what you actually want to log there is a custom event in CloudTrail. Last point here on the GXP side of things, and it is this concept of layers in GXP. So the worst thing you can do to yourself is when you bring a new instrument online, when you bring a new lab online, that you have to requalify. That's hell, because it's a very slow process. I've already dictated. And so what you want to do is break these down into stable, known good layers. So the AWS services, the GXP white paper kind of lists all the GXP eligible or GXP compatible services. It's almost everything, by the way. And then you want to think about a landing zone, which is like something you could build with Control Tower, but I want you to focus on the building blocks of the applications. What that means is when you have a validated storage solution and you bring that in-house for your enterprise, you want to say, hey, the search layer, validated. The storage layer, validated. And what that means is when you bring in new instruments, when you bring on new labs, you don't have to go into a qualification cycle. Just the adapter portions, the upper layer of the architecture needs validation, okay? And the other thing about this is if you actually follow the automation guideline, you have continuous validation, not one-time validation. It's super sketchy. That's not the right word. It's scary, or it's nerve-inducing, for me at least. Something is only validated every 6 months. And so that's another thing where automation helps you, is you see on a continuous basis whether you're succeeding your GQ, IQ, okay. Last thing, I talked a little bit about data integrity and checksums. Again, I think the notes here are to prefer cryptographically strong checksums, and you can see in the anatomy of a Quilt URL how we do link that code essentially is a SHA-256 hash. What does that mean? It is a hash of all the hashes of the constituents of the data set. And that's how people can trustlessly verify, yes, these numbers match and nobody has changed any of the data. That's part of it. Some tips in closing here. So you build for GXP components. This is both the building blocks and the AWS services layer under shared responsibility. You can, of course, rely on the vendor ecosystem for some of the higher level components. Store cryptographically strong checksums for each file. Again, I didn't talk a lot about book packages, but this is what they do automatically for you. Validate stable layers. Emphasize automation and use infrastructure as code for IQ. My concluding thought for you is that this concept of data integrity, I think compliance in one sentence is proving that you did what you said you did when you said you did it. And this is really the concept. What the ecosystem is missing is that data versioning buys with 80 or 90% of that. Because once you have the ability to time travel, you have this non-lineation, and you can go back in time and say, see, we said that it was done on December 29th. This is the checksum for that date. Anyone in the world can check it, and no one in the world could have falsified that data. And there are different pieces of integrity, both versioning, lineage, and checksums, on which I've touched on. And I think the interesting thing to think about, I think part of this spending $1 billion and getting half as many drugs every 9 years is inflation. I don't know how much we can do about that, but I do think that if you think about netbooking, you think about managing the integrity of your data for the full life cycle, that's what the standout startups in life sciences are going to do, and they'll be able to some extent, to counteract their inflow. That's all I wanted to say. I know it went super fast. There was a lot I wanted to say, but we'll make these slides available to everybody, and happy to take a quick question or two in the Somebody should break the ice. I also said something that didn't make sense.
I'll seize the room, but what advice would you have for a company getting started with AWS security? And as you mentioned, the AWS defaults are sometimes erring on the side of convenience and access and not straight security.
Yeah.
What would you say to someone starting out?
Yeah. Well, I think the first thing is to bring to everybody's attention this trade-off: security and usability are enemies. And this is why the defaults are really, 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 really hard to do right. Because if the totally most secure thing was the default, people would never be able to log into the security chain, right? Or it would take months and months and months. So the first thing is to be conscious of that trade. Some people have said that you want to think about your security as a hard outer shell. This is why I know networks are software. Think about a hard outer shell and a softer center, or a trustless center, probably the right way to think about that. So the first thing is to make people aware of that trade-off. And the second thing is to start to, again, this is not for super small startups, but as you scale, to start to look at control tower, start to look at service control policy, so that when people spin up resources, the controls are automatically baked in. Because what you don't want is every user makes their own S3 bucket. Each S3 bucket has a different resource policy on it. That's going to be called variability. And then I think KMS helps a lot too. And almost all the AWS services are exposed to KMS. Again, because you can go back to key policy, these call it key policy. And you can tell anybody with very high confidence. You need to store the past key policies. You can tell anyone with very high confidence. So only these people can access it. See, there's a little bit to think about in terms of ABAC there, but attribute-based access control, but I don't know, is there a question? I think so. One more, anybody?
Which parts do you usually see as most time-consuming for validation processors?
Which is most time-consuming for validation? I think it's the manual validation process. And I've seen that take like 3 to 6 months to set the test plan and then 3 months to execute. And the execution part is not even, that doesn't mean 9 months. It means 12 months because you have to schedule that 3 months from the quality team. So I think that the biggest thing, that's why I'm such a fan of automation here. And like, we want to partner with our customers to write canary to their specific business logic and just schedule them, because it's a lot cheaper and more efficient to put that human process into a machine than it is to expect someone to put it around. Yeah, I bring.
Hey, so about canaries, one of the requirements, depending on criticality of the system, is to have business application monitoring in place, which is like just constant checking if the app is running.
Right.
And so that's kind of what I like about canaries is you just have that on day one and you don't have to like make your own thing. With canaries, is there a way to like pull performance metrics over time for how long different activities are?
Yeah, there is. So there's 2 ways you can do that. One is you can export the data from the runs. Like you could see if we do like what's up and what's down over time. You would use like a database service, I think, in conjunction with that. I do have one question for you, and that's this business application monitoring. Where does that require to come from? Is that an internal control that you have, or is that like a vendor ask for that? I'm just curious.
Well, any company with their like computer systems lifecycle SOPs or standards, depending on the criticality, you would determine it, you need it, something like that. Thanks.
What I like about this business application monitoring engine is it sounds like a general IT goal, and that's how you get budget for this, right? Because you say like, hey, we're going to check a bunch of boxes at once. Usually you have budget in GXP to manufacturing, but you can also check them. Okay, I hope you found that interesting, and looking forward to some of the new presentations. I'm going to bring Adam and when growing these. Yes, still good.
But we can use immutable late just to, that's just an simple the.
Yeah, the question is automating IQ, OQ, and PQ acceptable by FDA? I'm gonna fall back on what the FDA said at reInvent. What they said is we encourage people to think about doing the right thing more than we do worrying about the regulations. So my position is, because the regulations are soft regulations and recommendations, that doesn't mean you could skip them. And because software systems especially are kind of at customer discretion, I think it absolutely would. And it fulfills the definitions of verification and validation. So from my perspective, I think it's totally legitimate. And if I were the FDA, or more importantly, if I were a customer buying from a startup that's doing manufacturing, this actually shows that you're ahead of the curve and that people understand the qualification better than most companies. So I think automation is the way to go. Okay, next.
Nice receipt.